So, just now we introduced the formation of the single covalent bond. Now here is about the formation of a double covalent bond. So, for example, in this case, carbon dioxide. So here we can see basically the oxygen has six electrons, and this oxygen has 6 electrons, and the carbon without carbon has 4 valence electrons. 4, 1, 2, 3, 4. Okay, so here we can see between the oxygen and the carbon, they share 4 electrons. 4 electrons, okay? And in this carbon and oxygen, they also share 4 electrons. Now we can see for oxygen, it has total 8 electrons. Yes. And how many electrons does the carbon have?
4.
Four?
In the bond.
8, yes. Because it is 4. These 4 are dissolved. And also it comes another 2 from this oxygen. 2 from this oxygen. So the carbon also has 8 electrons. So in this case, each atom has 8 electrons. So here we can see. So the carbon also has 8 electrons. So here we can see between the carbon and oxygen, they share 4 electrons. So these 4 electrons, we know 2 electrons is 1 bond. Okay, so 4 electrons, it means 2 bonds. 2 bonds. So between the oxygen and the carbon, it form a double bond. Double bond means there are 4 electrons. 4 electrons. So we can use this way to show the structure of carbon dioxide. So in the structure, there are between oxygen and carbon is 1 double bond. For oxygen, it is still, besides the double bond, it is still has 2 pairs of electrons. Okay. So this is about the double bond. This example to show the triple bond. So like nitrogen gas N2. We know nitrogen has how many valence electrons for nitrogen?
5.
Yeah, 5. Because it's like 2s2, 2p3. So it has 5 valence electrons. So in the structure is like this. In between there are 6. For these 6 electrons, 3, for example, we can say for this 3, this 3, okay, like this 3 from this guy, this 3 from this guy. Okay, so each one has 5 electrons, and the total electron number is 10, right? 6, 2, 2, 10. So each one has 5, so total they have 10 electrons. So in this case, they share 6 electrons. 6 electrons. So now we can say for each one we calculate the electrons number for each nitrogen. This guy, so 6, 2, so total 8 electrons. And also for this guy also has A electrons. We know if it has A electrons, so this means it's stable. So here, this shows 6 electrons, so it means for the formation of the triple bond. So triple bond means 6 electrons. 6 electrons. Okay. So here we introduced the formation of the single bond, double bond, and the triple bond, And when they form single or double or triple bond, each atom has A electrons. Okay. And of course, we can use the 3 short line to show the triple bond. So here we can see for different molecules, they may have different covalent bond. Maybe single bond, maybe double bond, maybe triple bond. Okay, here to show from the molecule like monoatomic and diatomic and also polyatomic molecules. So for example, in this case, right, this is like water. So water, it has like oxygen and hydrogen, the structure like this. Okay. So this slide shows the bond lengths, and also the bond types of some compounds. For example, for like if carbon and oxygen, they can be single bond, okay? So maybe double bond. But when it is double bond, it's shorter than the CO single bond. And for carbon, between two carbons, it may be single bond, double bond, or triple bond. And you can see for the distance, the triple bond is shorter than double bond, and is shorter than single bond. We know if the bond length is small, this means they are more close. And so this also means they are stable. Okay. And also for example, nitrogen is also can be single bond or double bond. So for the bond length, so usually the triple bond is less than double bond, and it's also less than single bond. And of course, the triple bond is much stable than the single bond. Okay, so here to show the difference, the difference between the properties of ionic compound and the covalent compounds. So here give 2 examples. One is sodium chloride, another CL4. So basically, we know for the ionic compound, they have a high melting point. And also they have high molar heat of fusion. So molar heat of fusion is like the amount of heat needed to melt one mole of solid. And also the boiling point of ionic compound is higher than that of covalent compound. compound. Okay, and also the solubility in water. So basically, the ionic compound is soluble. Can be sold in water. Okay, but for the covalent compound, they are solubility is very small. And also for the electric conductivity, basically, of course, the solid they are for, but the liquid for ionic compound is good. Okay, but for its poor. So why ionic compound can be electric can have the electric conductivity. Why? In solvent, in solution.
Because there are movement of electrons.
Yes, because in the solution, they are separate to become like a positive charge or electric charge, right? So they are ionic, so they can move. Okay, they can move under the under the in the electron field. Okay. So the second part is about the polar covalent bond. So there are two kinds of bonds. One is covalent bond, another is ionic bond. For covalent bond, there may be polar covalent bond. So what is polar covalent bond? Polar covalent bond is a covalent bond with greater electron density around one of the two atoms. So for example, in this case, we can see the fluorine, around the fluorine, it has more electrons. It has more electrons than hydrogen. We know they share these two electrons, right? But for these two electrons, more of them are close to the fluorine. So this means, so this side is electron-rich region, and this side is electron-poor region. So this looks like the fluorine has some minus charge, okay, and the hydrogen has some like positive charge, because the fluorine is electron-rich and hydrogen is electron-poor. So this has some minus charge and this has some plus charge. So this bond is called the polar covalent bond. So here we should know why the electron is more close to the fluorine, because hydrogen and fluorine, they have different electron activity. So do you still remember what is electron activity? Last time we introduced this concept. What is electron conductivity? Electron activity. The ability to attract the electron, right? The ability to attract the electron. We know the fluorine has the highest number, is 4, right? And for others, they can be calculated from their electron structures, and get some numbers. So, for example, electronegativity, fluorine is 4, and the hydrogen is only 2.1. 2.1, okay? So this means the ability of fluorine is much strong than the hydrogen to attract electron, Okay. So this table to show the electronegativity level of all elements. From this side, you can see this basically no metals have high values, right? Have higher values, and for these metals, they have low values. They have small values. Yeah. Okay. So, okay, here this picture to show us how to determine the properties of the covalent bond. We know covalent bond, so it may be this picture to show us how to determine the type of chemical bonds. So basically, we know for chemical bonds, they may be ionic bond, right? They may be covalent bond. It's like a equal, you can say like an equal covalent bond. Okay? They also may be polar covalent bond. Okay, so how to determine the bond type? We can just say the difference between their electron activity. We know there are electron activity, right? We know their values, right? We just compare the difference between their electron activity. So, for example, if the difference is 0, what does this mean? For two atoms, the difference of electron activity is 0. What does this mean? The cancel of atoms, they should be same or not? Yes, they should be same, right? If these two atoms are same, so of course the difference is 0. And when these two atoms are same, like H2, so definitely they are like equal covalent bond. Okay? So when the difference is larger than 2, this means they will form ionic bond. Okay, for example here, we saw that the x-axis is about the difference, electronegative difference. Okay, so this is about we can just see this line. If it's 0, difference is 0, like Cl2. Okay, so definitely it is covalent, equal covalent bond. If it's larger than 2, this side, right? So we can say this compound. In these compounds, the difference between these two atoms are more than 2. So they will form ionic bond. Here, for example, we can say all these compounds, like lithium chloride, right? Kf and here sodium chloride, right? Sodium chloride. So its difference is also more than 2. Okay, so it belongs to ionic bond. Okay, so this is when their difference is big. It's bigger than 2. they will form anion bond. So this means the one electron will move from one atom to another atom. But when the difference is between the 0 and 2, so they will form covalent bond. But this covalent bond is called polar covalent bond. Polar covalent bond. For example, between 0 to 2, so it's this compound, right? These compounds. So these compounds, we can see, they form polar covalent bond. Polar covalent bond. So any question for this picture? And any question for how to determine the bond types? Okay, so from here we can see if the difference increase, if the difference in electron negativity increase, so it will change from covalent bond to polar covalent bond, and then to anion covalent bond. So in anion covalent bond, they transfer electrons, okay? But in this, they just share, right? Share. But in this, they equally share. But for this, the electron, they still share electrons, but the electron may be more close to one of the atoms. Okay, now we know how to determine the bond types according to the difference. There are difference in electronegativity. Question. Classify the following bonds as anionic, polar covalent, covalent, or covalent. So the bond in this CSCl, H2S, and this is NN99 bond in this compound. Here to show there are electronegativity values. Okay, the first one, CSCl. So first you to know the difference, right? Of their, so how much?
It's
What's the CS?
1.3.
So CS, where? Here,
Yes.
0.7, right?
Yeah, really.
So what is chloride? 3.
Three.
So what's the difference?
2.3.
Yeah, 2.3. So what's the bond type and why?
Because the difference is larger.
Yes, it's larger than 2. Okay, so it's anionic bond. Second one, H2S. What's the difference between the H and S?
0.4.
So what is the hydrogen? Hydrogen 2.1, right? Sulfur 2.5. So what's the difference?
0.4.
Yes, 0.4. So it's between
But sir,
0 and 2, right?
Sir.
So it should be,
sir,
yeah, the second one, polar.
sorry, but it's H2. The 2 does not affect anything. The 2, yeah, H2. The
H2.
yeah, does not affect anything. I thought maybe
It doesn't, H2 is like, the structure. Oh, come on.
marker pen is there. On the
So how to, okay, the H2S like H, S, H, right? H, S, H, so like the bond between the HS. Here is HS. So it doesn't matter 2 or 3, We just discussed the HS bond. Okay? So yeah. So it doesn't matter 2 or 3 or something. So So of course, the 2 doesn't affect the timing. So the difference is between 0 to 2, so it should be covalent bond. It will be polar covalent bond. Okay, the third one, nitrogen bond between the in this compound.
Covalent.
What?
That's covalent.
Yeah. What's the difference?
0.
0. Yes, covalent bond. Okay. If we want, for example, nitrogen hydrogen. Nitrogen hydrogen.
Covalent.
What's the type between the hydrogen bond?
Covalent.
It's polar covalent. Yeah, polar covalent. Because what you can say, you can calculate the difference, right? Hydrogen 2.1, nitrogen 3. So what's the difference?
0.9.
Yeah, 0.9. So 0.9 between 0 to 2. So it should be polar covalent bond. So you just use this way to determine the bond types in compounds. Okay? Yeah, here is the answer, right? So the nitrogen, of course, are common. The first one is added more than 2. Between 0 to 2 is 0. Okay? Okay. So here to show another concept is about resonance structure. So what is resonance structure? So resonance structure is one of 2 or more Lewis structure for a single molecule that can't be represented by only one Lewis structure. So this is called resonance structure. For example, O3. We know O2, right? If one more O3 is O3. So O3 is often used in medical. Okay. So the structure O3 is structured like this. The Lewis structure. Between these 2 O3, there are 1 double bond. Between these 2 O3, there are 1 single bond. And for this O3, it loses 1 electron. For this O3, it gets 1 electron. So of course, this electron comes from this guy, right? So if you calculate the numbers of the O3, the numbers of electrons, you can find each O3 has A electrons. For example, this one, 1, 2, 3, 4, 5, 6, 7, 8. Here are 4, right? For this one, 1, 2, 4, 6, 8, right? 4, 2, 4, 2, 2. So 8, right? For this guy, 6, 2. Okay, it also has A electrons. So each one has A electrons. But this guy lose 1, this guy get 1. So this is 1. When we can use it this way, this is 1 Lewis structure. But this is also, in this structure, for each oxygen, it also has A electrons. The difference is, in this case, here is double bond. But in this case, here is double bond. You know, maybe you can say, oh, are they same? No, they are not same. Because, for example, we can name this oxygen A, B, C, right? And this is A, B, C. So in this case, the double bond is between A and B. But in this case, the double bond is between B and C. So here we can say, we can use these 2 structures to show, we can use these two formula, two structure to show the O3, right? So these 2 structures are called resonance structures. Okay? This means we can use not only one, we can use two. So these two structures are called resonance structures. Okay. Any question for this? Now, question. What are the resonance structures of the carbonate CO3 this iron? So basically, the structure is like this. This is carbon, this is the oxygen. And between the carbon and oxygen, there are one double bond, two single bonds. Single bonds. How to draw the resonance structures of this iron?
You can try. I trust you. Yeah, I chose you. And the monitor, I have the power to choose. I choose the body. Morris.
Morris.
Oh, yeah.
So basically, you also
Let me try it.
like this. Okay, this way you should draw this Lewis structure, and then after you get one, so you can think out that they are
Let me try.
resonance structure.
Let me try. I'll just try.
Go. So we will say how to do. You can do that. Nice. This is very nicely. See, take it directly. Do it on the PPT.
What are we doing?
But you know, 2 minus. This means one oxygen should have 2 more electrons. So which one has 2 more electrons in this case? Which one? Which oxygen has 2 more electrons? We can say one by one. So for this one, this is correct, of course. So this guy has A electrons, and the A electrons, and this is guy.
Now, 1, 2, 3, 4, 5, 6, 7.
Yeah, although it has A electrons.
Now, 1.
Okay, you should also like all this and the 2 minus. Okay, too much. Anyway, okay. So this is one structure, right? It's correct. Okay. So on the right is resonance structure. Good.
It just looks funny like this. We did it. This is the bonus of the long 2 plus 2 minus 10. That I use my whole the chip box like this.
Yes.
The shell.
That's all.
Yeah, really.
Good. So sometimes the resonance structures may be more than 2. In this case, the first case, 2, right? 2 resonance structures.
You can even show that there's 2 columns.
Yes, good. Good, perfect. Okay, yeah. So there are one double bond, two single bond, right? So in this case, the double bond between these two atoms, in this case in here, and in this case in here. So all these structures are called resonance structures of this atom, Okay? So yeah, like this. So basically, this guy has one man. This guy, right? Okay. Okay. How to
No.
Okay.
The one is the
how do they?
The one in the middle.
No.
The back.
Okay. Yeah, say we can use these three structures. And of course, they are different because we can learn like A, B, C, right? Okay. Okay. Here we introduce some exceptions to the octet rule. So basically, the compounds, we can use the octet rule to explain the structures of compounds. But there are some exceptions. They are not along this rule. So, for example, first is it's called the incomplete octet structure. For example, in this structure, for this center atom, it has only 4 electrons. 4 electrons. It doesn't have 8 electrons, but this compound is also stable. Okay. And for example, in this case, so how many electrons?
6.
In this one?
6.
Yeah, only 6. So this is called incomplete octet. But we know this compound also stable. So this means there are some exceptions to the octet rule. This is the first type. So the second type is called odd electron molecules. So for example, in this structure, in this case, so how many electrons on this guy, on nitrogen? Yeah, only 7, right? Yeah, but it's all stable. Yeah, it's stable. It doesn't have 8 electrons. It only has 7 electrons.
But it's stable.
Yeah, it's stable. There's some exceptions. So this means octet rule can't explain all compounds.
Oh.
Yeah, it can explain the structure of most compounds, but for some compounds it can't explain. So what does this mean? This means maybe in the future, people can raise a better theory to explain the structures of all compounds. It's like the development history of atomic theory, right? So do you still remember the history of atomic theory? So the people in different time, people raised different types, different atomic types, right? About the structure of atomic atoms. So now there's still some compounds we can't explain by octet. So the third one is about the expanded octet. So for example, for this number, so how many electrons? 8?
No. 6.
6? This is single bond.
2.
2.
Now,
Total.
counting there 12.
12, yes. So the sum has 12 electrons. It's more than A, right? It's more than A. Okay, so that's all for today. And give me your homework.
Your confusion.